So in this video, I'll be introducing Chapter 1 of Walker, Introduction to Physics. This picture is the kilogram. This was it's housed in France. It was called Le Grand K, and until 2019, this was the standard unit for what a kilogram means. Kilogram was redefined in 2019 to refer to fundamental physical constants. So there is no longer an artifact that is used for any of the international system of units measurements. The concepts, one of them is units and dimensional analysis. So what I was just talking about, the international system of units, System International, I don't know how to quite say it, I don't know French, but this is what SI stands for, and the E's have little marks over them, and I can never remember which way they go. But SI is the International System of Units. You may know it as the metric system. It's called the MKS system because it uses meters, kilograms, and seconds as the primary units. We'll also be looking at dimensional analysis. Dimensional analysis is a way to do a sanity check looking at your answers. If I ask you, how much time did it take you to go from your home to your place of work? And you say, about 15 miles. Well, you didn't answer the question, right? Because I asked how much time it took, and you gave me a length. So that's what dimensional analysis is about. It's about looking to make sure that the dimensions, so like the meters, the seconds, maybe meters squared if it's an area, meters cubed is a volume, making sure that all of the units work together correctly to give you what you're looking for. We'll also look at converting units. If you're used to working in inches and miles, and now we have to go to meters, you need to know how to do that. Scientific notation. This is something that most of you will probably already know, so I hope to just go through that very quickly. It's a way to write really big or really small numbers easily by using powers of 10. We will not worry about significant figures in this class. If you're taking lab class from me, we will worry about significant figures there. In the lecture class, there are enough new concepts and crazy things to keep track of that I'm not going to worry about significant figures. In general, just keep 3 significant figures on, or keep 3 digits in all of your answers, and I will be happy. We'll also look at order of magnitude estimation. It's almost like a guess, but it's an educated guess when you don't need to know the exact right answer for something, but you want to make sure you're close to the right answer. So you can use this in life to estimate something quickly, or you can use it in a physics problem or any other kind of problem just by getting to the final answer. And if the question was, I don't know, how old was this person when they died? And you come up with an answer of 58,000 years, you probably made a mistake. And a quick order of magnitude estimation will tell you that, yeah, that person probably didn't live for that long. So then you can go back and recheck your answers. Also, scalars and vectors. So a scalar is a physical quantity that has just a size. A vector has not only size but also direction. And we'll use the word magnitude a lot. Magnitude is another word for size.